Hi guys, I'm Putri Rahayu from Offering AC, and in this video I will explain about work energy principle. But before we get to that, we should define both work and energy. What is energy? Energy is ability to do work. What kind of energy we're gonna talking about in this video? We're gonna talking about kinetic energy. Kinetic energy is the energy due to motion. What is work? Work is an energy transfer. Work and energy are always going to be equal. When we calculate the kinetic energy of an object, the really good way to do it is to simply calculate the work. When we transfer energy to the object, it means that we did work. The amount of energy transferred by force is called work done by force. The formula to calculate the work done by force of the object is W equals Fd cosine theta. The work W done on a system by an agent exerting a constant force on the system is the product of the magnitude F of the force, magnitude D of the displacement of the point of application of the force, and cosine theta, where theta is the angle between the force and displacement factors. Work is scalar quantity. It means that work can be positive or negative. The work done by force is positive when the project of F onto D is in the same direction as the displacement. But when the project of F onto D is in the opposite direction as the displacement, the work done by force is negative. The units of work are newtons times meters, which we call joules. Joules are the same units that we measure energy. If we applied force F in the same direction as the displacement, then theta is 0 and cosine theta is 1. The equation gives W equals Fd. Our formula is W equals F times D. Remember that in Newton's second law, we have force formula F equals m times A. If we replace F in work formula with F in Newton's second law's formula, the equation gives W equals m times A times D. And remember too, in the kinematica formula, we have V final square equals V initial square plus 2 times A times D. Looking on this kinematica formula, I just gonna isolate A times D. So I get A times D equals V final square mean V initial square time divided by 2. And then we replace A times D in work formula with A times D in kinematic formula. And we get that W equals m times the quantity V final square mean V initial square divided by 2. If we multiply the terms of this expression, we get that W equals half m final velocity square mean half m initial velocity square. This quantity, 1/2 m velocity square, is we call the kinetic energy. So, the change in kinetic energy of an object is equal to the net work done on the object. The expression is often called the work energy principle. If the net work done is positive, the kinetic energy is going to increase and the object is going to speed up. If the net work done on an object is negative, the kinetic energy of the object is going to decrease, which means it's going to slow down. And so let's solve a simple question. We have a car. That car is moving from left to the right and we are applying a constant force of 10 newtons. So how would you figure out the work on that card? It is really simple. You just say work is equal to the force parallel. Again, it is going to be in the direction of that motion times displacement, and since we are given a force of 10 newtons times the displacement 5 meters, it's really simple to solve for that. So what is this going to be our work? It is simply going to be 50 joules. 50 joules. Now that is the amount of work that was done on the card. Hey guys, the material is done. Thank you for watching. Bye.